Something just happened 4 billion miles away that scientists said could not happen. A tiny frozen world, kicked out of the Planet Club almost 20 years ago, is doing something no telescope has ever caught before. And the story behind it is stranger than anything we expected from a piece of ice sitting at the edge of our solar system. 7 minutes is how long it takes light to travel from the sun to Earth. But the story we are talking about today comes from a place so much farther away that sunlight takes more than 5 hours just to reach it. That place is Pluto. And what scientists just confirmed about it is making people rethink everything they thought they knew about small, cold, forgotten worlds. For most of the last century, Pluto was treated like an afterthought. It was small, it was far away. And in 2006, a group of astronomers voted to strip it of its planet status entirely, turning it into what they now call a dwarf planet. For a lot of people, that felt like the end of the story. Pluto became a punchline, the planet that got kicked out of the club. But new information is proving that idea completely wrong. Using the James Webb Space Telescope, researchers have confirmed that Pluto is doing something that should not be possible for a world this small and this cold. It appears to be cooling itself down, using nothing but a thin layer of haze sitting in its own sky. Think about that for a second. A frozen ball of rock and ice sitting so far from the sun that daylight there looks like a deep twilight is somehow running its own private cooling system. Nobody expected that, and it took years of watching and waiting to prove it was actually happening. To understand why this discovery matters so much, you have to go back to how little we actually knew about Pluto before any spacecraft ever got close to it. For decades, even the most powerful telescopes on Earth could only see Pluto as a tiny, blurry dot of light. Scientists could track its orbit because that only required watching its position move slowly across the sky over time. But its size, its surface, and whether it even had an atmosphere at all remained a mystery. Some early guesses about its size were wildly wrong, based on math that later turned out to be flawed. Then, in 2015, everything changed. After a 9.5-year journey across billions of miles of empty space, NASA's New Horizons spacecraft flew past Pluto. It only got one chance. There was no slowing down, no orbiting, just a few short minutes to capture as much data as possible before flying off into the darkness forever. What it sent back stunned scientists everywhere. Pluto had a massive, pale, heart-shaped plain stretched across its surface. It had mountains made of solid water ice rising more than 10,000 feet into a hazy sky. It had fields of frozen nitrogen that appeared to be slowly shifting and moving, which suggested heat was doing something beneath a crust that everyone assumed was completely dead. And layer after layer of blue haze rose hundreds of miles above the surface, glowing faintly even when lit from behind by the sun. Pluto did not look like a dead leftover chunk of ice. It looked like a world that was still active, still changing, still doing something. But New Horizons could only take one look before it kept flying. Whatever it missed would remain a mystery for years, because there was no way to send another spacecraft back anytime soon. That is where the James Webb Space Telescope stepped in, and it approached the problem in a completely different way. Instead of flying past Pluto and snapping a photo, Webb reads light itself. It breaks that light apart into its individual wavelengths, which lets scientists figure out the exact chemical makeup of whatever they are looking at, all from millions of miles away. Pointed at Pluto, which from Earth looks like nothing more than a faint speck of reflected sunlight, Webb can tell researchers what molecules are floating in its atmosphere, how warm different layers of that atmosphere actually are, and how all of it changes over time. And it can do all of this without ever leaving its post near Earth. But there was one major problem standing in the way. Pluto sits so close to its largest moon, Charon, that separating the heat signals coming from each one was nearly impossible using older telescopes. For years, scientists tried and failed to detect the exact signal they were looking for, not because it did not exist, but because their equipment simply could not tell how much of the heat was coming from Pluto and how much was leaking in from Charon sitting right next to it. It would take a much bigger, much more sensitive telescope to finally crack that problem open, and that telescope was just getting started. Picture standing under a blanket on a freezing night, expecting it to keep you warm, and instead it starts pulling the heat straight out of your body. That is basically what is happening on Pluto right now, and it took scientists years to actually believe it themselves. Once the James Webb Space Telescope finally solved the problem of separating Pluto's heat signal from its neighboring moon, researchers turned their full attention toward one specific mystery that had been sitting unanswered since 2015. Back then, New Horizons had photographed layers of blue haze wrapped around Pluto, rising hundreds of miles above its surface. Everyone could see the haze was there. What nobody could prove was what that haze was actually doing to the world underneath it. In 2017, a planetary scientist named Xi Zhang, working at the University of California, Santa Cruz, put forward an idea that sounded almost backwards at the time. On Saturn's moon Titan, a similar kind of haze traps heat and keeps the surface below it warmer than it would otherwise be. Zhang argued that Pluto's haze might be doing the exact opposite. Instead of trapping heat like a blanket, the haze could be soaking up sunlight during the day and then throwing that energy straight back out into space as infrared heat, faster than Pluto's paper-thin atmosphere could ever hold onto it. In other words, the haze was not warming Pluto. It was actively cooling it down, working more like a radiator than a blanket. At the time, a lot of scientists were skeptical. It was a strange claim, and there was no instrument on Earth capable of actually testing it. That changed once Webb's infrared instrument became sensitive enough to isolate Pluto's own heat signal from that of its moon. A team, led by astronomer Tanguy Bertrand at the Paris Observatory, used that instrument to measure Pluto's atmosphere directly, and the results were published in the journal Nature Astronomy in June of 2025. What they found lined up almost exactly with what Zhang had predicted 8 years earlier. Pluto's upper atmosphere really is being cooled by the haze particles floating inside it, and it turned out to be roughly 30 degrees Fahrenheit colder than earlier models had predicted. Scientists are now calling this a genuinely new kind of climate, one that behaves differently from every other atmosphere we have ever studied anywhere else in the solar system. Pluto is not simply cold because it happens to sit far from the sun. In a very real way, Pluto is actively refrigerating itself, using a process that nobody expected to find on a world this small. Researchers are still trying to figure out how far this discovery reaches, including whether similar hazes might be quietly shaping conditions on other distant, hazy worlds like Neptune's moon Triton, or even hinting at what Earth's own sky may have looked like billions of years ago, long before oxygen ever built up in our atmosphere. There is a second part to this haze story, and it is quieter, but just as strange once you really sit with it. Even the extremely faint sunlight that manages to reach Pluto is enough to break apart methane molecules high up in its atmosphere. Those broken pieces do not just disappear, they recombine into heavier compounds, forming a slow chemical process that eventually creates reddish-brown particles called tholins. Those particles slowly drift downward and settle onto Pluto's surface. New Horizons picked up early traces of this process back in 2015, and more recent observations have helped scientists understand exactly how it works. Here is the detail that tends to stop people in their tracks. Tholins belong to the same general family of organic molecules that some scientists believe may have once rained down onto early Earth, potentially providing some of the raw material that eventually led to life here. On Pluto, that same basic process has apparently been running for roughly 4 billion years straight. It is a slow, ongoing snowfall of the building blocks of life, landing on a surface so frozen that none of it could ever spark into something alive. To understand just how extreme that cold really is, it helps to look at the actual numbers. Sunlight reaching Pluto is about 1,000 times fainter than sunlight reaching Earth, meaning even high noon there would look closer to a heavy twilight here. Surface temperatures on Pluto generally sit somewhere between about negative 387 and negative 369 degrees Fahrenheit. That is more than 250 degrees colder than the coldest temperature ever recorded anywhere on Earth. At those kinds of temperatures, nitrogen, the same gas that makes up most of the air you're breathing right now, freezes completely solid. Somewhere out past Neptune, one small world has been quietly stealing pieces of its neighbor for billions of years, and it left the evidence stained right onto its own face for anyone to eventually notice. For a long time, scientists knew Pluto was slowly losing its atmosphere. Methane and other light molecules drift upward through the thin air, slip past Pluto's weak gravity, and escape into space. That part was never really in question. What puzzled researchers for years was a much simpler question. Where was all of that escaping material actually going? It was not just disappearing into empty space. Something was catching it. That something is Charon, Pluto's largest companion, a battered ice moon roughly 750 miles across, locked in an extremely tight gravitational bond with Pluto. Most of Charon's surface looks fairly plain, just ancient, heavily cratered water ice. But at its poles, something strange stands out. The ice there is stained a deep, unmistakable reddish-brown, darker than anything else visible anywhere on the moon. For years, scientists suspected this coloring was somehow connected to material leaking off of Pluto, but they had no real way to prove it. The answer turns out to be tied to how strangely long Charon's seasons actually are. Because of the way Charon tilts as it orbits alongside Pluto, its northern pole spends multiple decades sitting in complete darkness with no sunlight reaching it at all. That makes the pole an extremely effective trap for cold. Methane molecules escaping from Pluto drift across the gap between the two worlds, arrive at Charon's dark pole, and freeze solid onto the surface simply because there is no warmth there to keep them as gas. They sit there building up for years, decade after decade, waiting for sunlight to finally return to that part of the moon. When sunlight does come back, it does not just melt that frozen methane away. Instead, ultraviolet light and cosmic rays break the frozen molecules apart and reassemble the pieces into heavier, more complex reddish compounds. This locks the dark coloring in permanently instead of letting it fade or evaporate back into space. A widely cited study from 2016 first laid this process out clearly, showing that methane escaping Pluto's atmosphere crosses roughly 12,000 miles of space, gets pulled in by Charon's gravity, freezes onto its cold pole, and is then slowly cooked by sunlight and radiation into the same kind of heavy organic compounds that also color parts of Pluto's own surface. Two worlds, locked together, quietly trading atmosphere and color back and forth for longer than either one has had a name. Charon had one more surprise waiting as well. In October of 2024, a team led by researcher Silvia Protopapa at the Southwest Research Institute used Webb data to confirm that both carbon dioxide, the same gas leaving your lungs with every breath, and hydrogen peroxide, the same compound sometimes used to clean a wound, are frozen directly onto Charon's surface. According to the research, the carbon dioxide most likely came from underground material that got exposed by impact craters hitting the moon over time. The hydrogen peroxide, on the other hand, appears to have formed from years of radiation striking Charon's water ice and slowly rearranging it into something new. Scientists noted that this exact combination of frozen chemicals had never been confirmed on Charon before, adding yet another layer to a moon that keeps turning out to be far more chemically complicated than its plain, icy appearance would ever suggest. Take a moment to actually picture what this relationship looks like up close, because it is unlike anything else in our solar system. Pluto and Charon are close enough in size that they do not orbit each other, the way Earth orbits its own moon. Instead, they both orbit a shared point sitting in empty space between them, locked so tightly that each one always shows the exact same face to the other. It is a silent standoff that has been running for billions of years. Two worlds permanently frozen in place relative to each other, endlessly trading atmosphere, chemistry, and color, while neither one ever gets a different view of its neighbor. What makes this discovery so important is that it changes how scientists think about small, icy worlds in general. This is not just a one-time coincidence between two random objects. It suggests that when a small planet and its moon sit close enough together, they can end up locked into a long, ongoing chemical relationship, shaping each other's surfaces over billions of years, completely invisible to anyone watching from Earth, until a telescope powerful enough finally came along to catch it happening. Somewhere beneath a shell of ice 100 miles thick, there might be an ocean that has never once seen sunlight, sealed away in complete darkness since before complex life even existed on Earth. New Horizons captured something back in 2015 that scientists are still arguing about today. In a region they named Tartarus Dorsa, the spacecraft photographed tall rows of jagged ice blades, some rising more than 1,500 feet high, made of frozen methane and lined up in long parallel ridges. Similar but much smaller versions of these formations exist here on Earth, found in certain high-altitude deserts, where they rarely grow taller than an average person. Scientists believe the Earth versions form through a slow process where sunlight causes uneven melting across an icy surface, carving taller sections, while lower areas wear away faster. On Pluto, the same basic process appears to have played out on a massive scale, over a much longer stretch of time, using frozen methane instead of frozen water. A 2025 analysis of the original New Horizons data suggests these towering ice blades may wrap around as much as 60% of Pluto's equator, forming an entire ring of jagged, frozen terrain circling the dwarf planet. Elsewhere on the surface, a massive dark region, roughly the size of Alaska, stretches across the equator, colored a deep reddish black. This is where the falling tholin particles, the ones created by sunlight breaking apart methane high in the atmosphere, have apparently piled up thickest over billions of years, landing on some of the oldest and most exposed ground anywhere on Pluto. South of the famous pale heart-shaped plain, two enormous isolated peaks rise out of the landscape, and researchers still cannot fully explain them. One stands roughly 13,000 feet tall. The other may reach close to 20,000 feet, with a base wide enough to rival some of the largest volcanoes on Earth. Both mountains have deep depressions at their summits, ringed by cracks, with lumpy, uneven sides that closely resemble cooled lava flows. Except there's no molten rock anywhere on Pluto. If these features are what they appear to be, they are cryovolcanoes, structures that once erupted not with melted stone, but with a thick slurry of water, ammonia, and methane forced upward from somewhere deep beneath the icy crust. Scientists are still divided on whether this came from a handful of massive eruptions or many smaller events spread out over a longer period. Either way, both explanations point to the same unsettling idea. Something, at some point in Pluto's fairly recent history, was warm enough underneath that frozen shell to push liquid material all the way up to the surface. That internal warmth leads directly to one of the most debated ideas surrounding Pluto today, the possibility of a hidden ocean sitting roughly 100 miles beneath the surface, kept liquid by the slow radioactive decay of elements inside Pluto's rocky core. There is no photograph proving this ocean is real. What scientists have instead is a pattern. Cracks and ridges across Pluto's surface line up in ways that match what you would expect from a layer of liquid water shifting slowly underneath the crust. And that same famous heart-shaped plane sits directly above what appears to be a positive gravity anomaly, a spot where something denser than the surrounding ice may be sitting underneath. This idea matters more than it might first seem, because similar hidden oceans are already strongly suspected beneath the icy surfaces of Europa, one of Jupiter's moons, and Enceladus, one of Saturn's moons, both of which show far more obvious evidence, including geysers of water vapor shooting directly into space in Enceladus's case. If a small, cold world like Pluto turns out to be hiding something similar, it would suggest that buried oceans might be a far more common feature of icy worlds throughout the outer solar system than scientists previously believed, rather than a rare exception limited to a handful of larger moons closer to the Sun. Right now, there's no way to confirm any of this directly. There's no funded mission planning to send another spacecraft back to Pluto, no lander, no orbiter currently on the books, largely because the journey alone would take the better part of a decade, and outer solar system missions have rarely been treated as a funding priority. For now, the James Webb Space Telescope remains the only working tool checking back in every few months whenever Pluto swings back into view, adding another small piece to the picture each time. Pluto sits inside the Kuiper Belt, a massive ring of icy debris beyond Neptune's orbit, home to hundreds of thousands of objects, and an estimated trillion or more comets. A handful of other bodies out there come reasonably close to Pluto in size. Beyond the Kuiper Belt entirely lies the theorized Oort cloud, thought to hold another trillion or so icy bodies, stretching outward roughly a quarter of the way toward the nearest star. Only one spacecraft has ever gotten close enough to photograph any of these worlds up close, and it only managed flybys of 2 of them. Pluto was never really the dead end that a single vote in 2006 made it look like. It turned out to be the beginning of a whole set of questions scientists are still learning how to ask. And if one small, frozen, dismissed world was hiding this much beneath its surface, it is worth wondering what else is sitting out there in the dark, still waiting to be noticed.